Hi guys, welcome to today's tutorial. Today we'll be looking at number-based systems on how to convert from a larger base numbers to smaller base numbers and vice versa. Now, our first example says convert 824 base 12 to denary. Now, in doing this, we would use our expansion method. And using our expansion method, we simply have it as 824 base 12. This becomes 0, 1, 2. Alright, so this will be 8 times 12 raised to power 2 plus 2 times 12 raised to power 1 plus 4 times 12 raised to power 0. Now this will give us 8 times 144 plus 2 times 12 plus 4 times 1. Alright, so this gives us 1152 plus 24 plus 4, which eventually will give us 1180 base 10. Now, with this, we've converted our 824 to base 10. Our next example talks about convert 2A5 base 16 to binary. Now, in converting from base 16 to binary, we have it as 2A5 base 16. So this becomes 0, 1, 2. So this becomes 2 times 16 raised to power 2 plus A is 10. Alright, A is 10. So this 10 times 16 raised to power 1 plus 5 times 16 raised to power 0. Now 16 raised to power 2, that's 16 times 16 would give us 256. 2 times 256 plus 10 times 16 plus 5 times 1. So this gives us 256 times 2, 512 plus 160 plus 5, which eventually would give us 677 base 10. Now, since we are converting back to base 2, which is binary, that means we'll divide 677 by 2. So this becomes 2677. How many times will 2 go in here? 263, 273, 273, remainder 1. Now 2 here, we have it as, 2217 will be 8. Okay, 2271, remainder, into 73, remainder 1, into 17, 18. Okay, that is 16, remainder 1. Now 2 into this, 2 here, 1, remainder 1, into 13 is 12, so 6, remainder 1, into 18 is 9, remainder 0. Now 2 again here will give us into 1, 0, into 16, 8, into 9, 4, remainder 1. 2 into 84 will give us 4, into 4, 2, remainder 0. 2 here will give us 2, 1, remainder 0. 2 here will give us 1, 0, remainder 1. 2 here will give us 5, remainder 0. 2 here will give us 2, remainder 1. 2 here will give us 1, remainder 0. And 2 here will give us 0, remainder 1. So reading it upwards, we have our answer as 101, 01, 00101 base 2. So this gives us our answer as 101. Okay, so our 677 base 10 equals to this. Convert 2324 base 4 to hexadecimal. Now, in converting this, we'll first of all convert this to base 10, which will become 4 times 2 raised to the power 3. Sorry, the other way around. 2 times 4 raised to the power 3 plus 3 times 4 raised to the power 2 plus 2 times 4 raised to the power 1 plus 4 times 4 raised to the power 0. Okay, so this gives us 4 raised to the power 3 will give us 4 times 4 times 4, that's 64, plus 3 times 16 plus 2 times 4 plus 4 times 1. Now 2 times 64 will give us 128 plus 16 times 3 will give us 48 plus 8 plus 4. So this gives us 188 base 10. Okay, now having it as 188 base 10, converting to base 16, that means we are converting 188 base 16. So 188 divided by 16, we are having 11 remainder 12. Okay, and 16 here will give us 0 remainder 11. Okay, now having this, we know that we have our numbers from 1 to 9, then A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15 for hexadecimal. So here will become 12 will be C and 11 will be B. So reading upwards, 188 base 10 in hexadecimal will become BC base 16, which is our answer. Convert 11100 base 2 to base 5, our octal base system and geodecimal. Now, base 5 is clear that we are converting it to base 5. Octal is base 8. Okay, and geodecimal is base 12. Alright, so we have to convert from base 2 to base 5, base 8, and base 12. Now, let's get right into it. Now, converting from base 2, we have 111001 base 2. Okay, so first off, we convert to base 10, then we convert to this other bases. Now, converting to base 10, this will be 0, 1, 2, 3, 4, 5. So this will be 1 times 2 raised to the power 5 plus 1 times 2 raised to the power 4 plus 1 times 2 raised to the power 3 plus 0 times 2 raised to the power 2 plus 0 times 2 raised to the power 1 plus 0 times plus 1 times 2 raised to the power 0. So 2 raised to the power 5 is 32 plus 16 plus 8 plus 0 times this will give us 0, 0 plus 2 raised to the power 0 is 1, 1 times 1, 1. So adding this up, this gives us 40, 50, 56, 57. So this gives us 57 base 10. Now, since we know that base is 57 base 10, okay, since we know that this is 57 base 10, so our A part to base 5 will become 557. Now this will give us 1 into 10 into 7, 1, remainder 2. 5 into 11 will give us 2, remainder 1. And 5 into 2 will give us 0, remainder 2. So reading upwards, 57 base 10 will give us 212 base 5. Now, converting to octal, which is base 8, this becomes 57 into 8. Okay, now 57 divided by 8 would give us 7. 7 times 8 will give us 56. Okay, so this will be remainder 1. So this will be 0 remainder 7. So our 57 base 10 will give us, reading upwards, 71 base 8. We've come to the end of today's tutorials. Don't forget to like, subscribe, click on the notification buttons for more updates. If there be any questions, put them down in the comment section below.